Hello everyone, welcome to the video on LeetCode problems by Intellipaat. In today's video, we will cover LeetCode problems. First, we will discuss best time to buy and sell stocks, then we will discuss count and save problem. If you are an engineering student and preparing for placements, then this video is going to help you in mastering DSA concept. By the end of this video, you will have a solid understanding of how to solve count and save problem and gain insights into trading strategies for best time to buy and sell stock. But before we dive into the session, I would like to request you to enable both the subscribe button and bell icon for Intellipaat YouTube channel so that you won't miss out any updates coming from our team. So let's begin with today's agenda. We will start by understanding the best time to buy and sell stocks problem. Then we will try to come up with different problem solving methods and analyze their time and space complexity alongside. Later on, we will cover the coding solution for optimal approach using C++ programming language. After that, we will move on to the count and save problem. Once we understand the problem, we will analyze the problem solving approaches we can imply and develop solution using C++ programming. I hope I have made myself clear with the agenda for today's video. So let's try to understand the problem, best time to buy and sell a stock. Here we have given an array of prices where the prices of I is the price of a given stock on the ith day, and we have to maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And we have to return the maximum profit that we can achieve from this transaction. Also, if we cannot achieve any profit, we simply have to return 0. So, what exactly does this problem say? In this problem, we have given the prices of a stock on different days. For example, suppose we have a stock X and the prices for stock X on day 1 is 7, on day 2 is 1, on day 3 is 5, on day 4 is 3, on day 5 is 6, and on day 6 is 4. Here what we have to do is, first we have to buy the stock and then sell in such a way that it gives the maximum profit. Like if we buy on day 1 and sell it on day 2, it means we are buying the stock at 7 and selling it at 1. So we will get a loss of 6 rather than profit. Similarly, if we sell on day 3, we will get a loss of 2. And if we sell on day 4, we will get a loss of 4. And if we sell on day 5, we will get a loss of 1. Similarly, if we sell on day 6, we will get a loss of 3. So it's not profitable to buy on day 1. Suppose we buy the stock on day 2 and sell it on day 3. We will get a profit of 4. But we will continue to check for other days because we want to get maximum profit. So if we sell it on day 4, we will get a profit of 2, which is less than the profit we had. If we sell it on day 5, we will get a profit of 5, which is maximum profit till now, but still we will check for other days. If we sell it on day 6, we will get a profit of 3, which is not maximum profit. In a similar way, we will check for all the possibilities. Here, we can conclude that by buying the stock on day 1 and selling it on day 5, we are getting the profit of 5, which is the maximum among all the possibilities. Hence, we will return 5 as the final output. One more thing to note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Now, let's try to understand this problem using arrays. We will iterate through the array for I and j using a nested loop. Here, I is for buying and j is for selling. In outer loop, we will start iterating from I is equal to 0, and in inner loop, we will start iterating from j is equal to I plus 1. Now, at index I is equal to 0, we have element 7, and at index j is equal to 1, we have element 1. When we subtract 7 from 1, we will get a loss of 6. Then we will iterate further for I is equal to 0, and at j is equal to 2, we have element 5. Now, when we subtract 7 from 5, we will get a loss of 2. At j is equal to 3, element is 3. When we subtract 7 from 3, we will get a loss of 4. At j is equal to 4, element is 6. When we subtract 7 from 6, we will get a loss of 1. At j is equal to 5, element is 4. When we subtract 7 from 4, we will get a loss of 3. Now, moving to I is equal to 1 and j is equal to 2. At I is equal to 1, element is 1 and at j is equal to 2, element is 5. When we subtract 1 from 5, we will get 4, which is a profit, but we need to traverse further for finding maximum profit. So at index j is equal to 3, element is 3. When we subtract 1 from 3, we will get 2, which is profit but not maximum profit. At index j is equal to 4, element is 6. When we subtract 1 from 6, we'll get 5, which is maximum profit till now, but still we will traverse further. Now at index 5, element is 4. When we subtract 1 from 4, we'll get 3, which gives profit but not maximum profit, which is 5. We will continue this process for all possible I and j combinations. The maximum profit we find in this manner is 5, which occurs when we buy on day 2 and sell it on day 5. Now let's look into the algorithm. Let's declare an array named prices. Suppose initially maximum profit is 0. Now we will traverse through the array for I and for j. Now we will calculate the profit, which is equal to prices at index j minus prices at index I. Now suppose profit is greater than maximum profit, then we will update the value of maximum profit to profit. For example, at I is equal to 0 and at j is equal to 2, profit is equal to prices at index 2 minus prices at index 0, that is equal to 5 minus 7, which is equal to minus 2, which is less than the maximum profit, which is 0. So in this case, we will not update the value of maximum profit. Now let's take one more example. At I is equal to 1 and j is equal to 4, profit is equal to prices at index 4 minus prices at index 1, that is equal to 6 minus 1, which is equal to 5. Here we can see that profit is greater than maximum profit, hence we will update the maximum profit to 5. Now let's try to execute the code. Here we have given a function max profit which take references to a vector integer as a parameter. Now we need a variable to store the value of maximum profit. So let's take that int max profit. Now we will initialize it to 0. After that, we will start traversing through the loop for I and j. For int I is equal to 0, I should be less than prices dot size, and now we will increment in I, that is I plus plus. Now for int j is equal to I plus 1, j should be less than prices dot size, and now j plus plus. After that, we will find another variable profit. Let's do that int profit, now which is equal to prices of j minus prices at I. Now we will check the condition between profit and maximum profit, like if profit is greater than max profit, then we will update the value of max profit to profit, like max profit is equal to profit. Now finally we will return the maximum profit. We return max profit. Now coming to the main function, we have the prices on the different days, and after that we are calling the max profit function and storing its value in result, and finally we are printing the result. Now let's try to execute the code and see output. Here we can see that the maximum profit, which is equal to 5. Now what do you think about time complexity for this code? Well, it's order of n square. Time complexity is the amount of computational time a program or algorithm requires to solve a specific problem. So lower time complexity generally indicates more efficient algorithm. Since the time complexity for this code is order of n square, so we will discuss another approach for better time complexity later in this video. Now, what is a space complexity for this code? Well, it's order of 1, which is considered as good space complexity. A space complexity is the amount of memory or storage space an algorithm or program requires to solve a specific problem. So, lower space complexity generally indicates a more efficient algorithm. Now, let's discuss one pass approach for better time complexity. First, we will declare minimum price and initialize it to prices at index 0. Then, we will declare maximum profit and initialize it to 0. Now, we will start iterating for I is equal to 1. If the prices at index I is less than minimum prices, then we will update the value of minimum prices to the prices at index I. Else, we will declare the variable current profit, which is equal to the prices at index I minus minimum prices. Then we will compare the value of maximum profit and the current profit and return the value which is maximum among both. Now we will start iterating for I is equal to 1. Prices at index 1 is 1 and the minimum price is 7. And here the maximum price is 0. Now we will compare the prices at index 1 and the minimum price. Here we can see that the prices at index 1 is less than the minimum price, hence we will update the minimum price to 1. At I is equal to 2, the prices at index 2 is 5 and the minimum price is 1. Here the prices at index 2 is greater than minimum price, so we will go to else part and will find the current price, which is equal to the prices at index I minus minimum price, and which is equal to 4. Now we will compare the current price and the maximum price. The maximum price is less than current price, so we will update the maximum price to 4. Now coming to I is equal to 3. The prices at index 3 is 3 and the minimum price is 1. Here we can see that the prices at index 3 is greater than minimum price, so we will find the current price which is equal to 2. Then we will compare the current price with the maximum price. Here we can see that the maximum price is greater than current price, so we will do nothing and move forward. Now coming to at index 4. The prices at index 4 is 6 and the minimum price is 1. Here the prices at index 4 is greater than the minimum price, so we will find the current which is equal to 5. After that we will compare the current and the maximum price. Here we can see that the current price is larger than the maximum price, so we will update the maximum price to 5. Now that's all. Now let's try to execute the code. Here we have given a function named maxProfit which takes references to a vector of integer as a parameter. Now inside the function, first we will check whether the prices vector is empty or not, and if it is, we will return 0, like if prices dot empty. Then we will simply return 0. Now we will declare a variable to store minimum price in the list and initialize it to prices at index 0. Let's do that. Int min price is equal to prices at index 0. After that, we need a variable to store maximum profit and we will initialize it to 0. Let's do that. Int max profit, and let's initialize it to 0 is equal to 0. Now we will start iterating through the loop for I. For int I is equal to 0. Here we will start from I is equal to 1. I should be less than prices dot size and I plus plus. Now we will check the condition between prices at index I and the minimum price, like if prices at index I and minimum price. Here if prices at index I is less than the minimum price, then we will update the value of minimum price to the prices of I, like min price is equal to prices at index I. If this condition is false, we will declare another variable to find the current profit. So we will go to the else part. Else int current price is equal to prices at index I minus min price. After that, we will compare the maximum profit and the current profit and then return which gives the maximum profit. Like here, max profit is equal to max profit and current profit. And finally, we will return the maximum profit. Return max profit. Now coming to the main function, we have the prices on different days. And here we are calling the max profit function and storing its value in result. After that, we are printing the result. Now let's execute the code and see the output. Here we can see that the maximum profit is 5, which we have already discussed. Now, what do you think about the time complexity for this code? Well, it's just executing in big O of n time. And talking about a space complexity, it is just executing in big O of 1, that is constant. Now, let's jump to our next problem, that is count and say problem. So, what exactly does this problem say? The problem is count and say. This means we have to count the number first, then we have to say which number is that. Let's try to visualize this. Suppose we have a number 3335211. Here we can see that the frequency of 3 is 3, so we will write 3 and the number itself. Now moving forward, the frequency of number 5 is 1, so we will write 1 and the number itself. Now moving forward, the frequency of number 2 is 1, so we'll write 1 and the number itself. And finally, the frequency of number 1 is 2, so we will write 2 and the number itself. Hence, we will return the output as 33151221. Now moving forward, for n is equal to 1, we will simply print 1, as this is the base case according to the question. For n is equal to 2, we will look at the previous and take the total count of the number, and it is 1, so we will write 1, then we will write the number itself. Now for n is equal to 3, the total count of 1 is 2, so we will return 2 and the number itself, that is 1. Now for n is equal to 4, the total count of 2 is 1, so we will write 1 and the number itself, that is 2. Then we will count the number 1 and it is 1, so we will write 1 and we will write the number itself, that is 1. Now let's try to understand the algorithm. Suppose we have a number 7766665. We will check if the current digit, that is at position I, is same as the next digit, that is at position I plus 1. Then if they are same, it increments the count variable. Now if the current digit, that is at position I, is not same as the next digit, that is position I plus 1, then we will add this to the result. At this point the result becomes 27. Now moving forward, we can see that the digits are same, so we will simply count plus plus and move. Here also the digits are same, so we will do count plus plus and move. Here the digits are different, so we will add the result to the result. That is, till here it is 2736. Now here the loop reaches the end, so it adds 15 to the result. At this point it becomes 273615. I hope we are clear with the question. Before we execute the code, let's have a quick recap about recursion. The recursion is a programming or mathematical concept where a function or a process calls itself in order to solve a problem or perform a task. Here, it consists of two parts. The first one is base case. In this, we check for the value 0 or 1. And other is recursion case. In this part, the function calls itself and breaks down the problem into a smaller or the subproblem. Now let's try to execute the code. Here, we have given a function count and say which takes integer as a parameter. Now inside the function we will write the base case, that is if n is equal to 1, we will simply return 1. After that, we will call the function recursively for a smaller output, that is till n minus 1th term of the sequence, and store it in a variable. So let's do that. String priv is equal to, now we are calling the function count and say till n minus 1th term. Now we need an empty string to store the result. So let's create that. The string result is equal. It is empty, so let's keep it like this. After that, we will declare a variable for counting the frequency of similar digits and initialize it to 1. So let's create that int count and we will initialize this to 1. Now we will iterate through the array for I. So for int I is equal to 0, I should be less than previous dot length and I plus plus. Now we will check two conditions. The first is whether the digit at the current index is equal to the digit to the next to it, and the second condition is it must not be the end of the list. If this condition is true, we will return the count plus plus. So let's do that. I plus 1 is less than previous dot length, and the second condition is previous of I is equal to previous of I plus 1. If this condition is true, we will return count plus plus. Now, if this condition is false, then we will store the result. Like, we will go to the else part, else, and store result. Result plus is equal to string. Here we are converting the count to string. Count plus previous of I, prev of I. After this, we will initialize the count to 1, like count is equal to 1. And hence we will return the result. Return result. Now coming to the main function, here n is equal to 5, and here we are calling the function count and say and storing its value in the result, and finally we are printing the result. So let's execute the code and see the output. Here the output is 1 1 1 2 2 1. Now let's change the value of n and see the output. Suppose n is equal to 1. Let's execute the code and see the output. Here we can see that when n is equal to 1, it is giving the output 1. And let's check it to n is equal to 2. Let's execute and see. Here we can see that at n is equal to 2, the output is 1 1. What if n is equal to 3? Let's execute and see. Here we can see that at n is equal to 3, it is 2 1. Here we can see that we are getting the output as we have discussed. Now, what do you think about the time complexity for this code? Well, it's order of n cross m. And what do you think about the space complexity for this code? Well, it's order of m. That's all about today's video. But before we end, let's discuss best way to solve LeetCode problems. The very first step is to understand the question. Then try to solve using brute force. Once you are done with these, then try to implement them into code. At this point, you have a good idea of the problem, so try to optimize the solution for better time and space complexity. We hope this video has provided you with valuable insights into solving these LeetCode problems. And we encourage you to explore and master more data structure and algorithms. And don't forget to subscribe to Intellipaat YouTube channel to stay updated with more useful contents.
Just a quick info guys, Intellipaat offers full stack web developer course in collaboration with E&ICT Academy IIT Guwahati. Through this course, you can learn everything from front-end web development to back-end web development from esteemed IIT Guwahati faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in the field of web development.